Hi, ecs251 students. So today we're going to have two presentation that's going to show their demo. So I actually gave that some guideline about 5 minutes for the three issue you need to deal with. That's actually for next week. So that's actually because today we're in class, we're lecturing mode. So we're going to have more time to discuss the topic, okay? Yeah. All right. So whenever you're ready, you can, you're gonna go first? Okay, perfect. So I already turned on the share screen. Let me just, you can have all the. Okay, so yeah, please take away the screen and it's all yours.
Can you guys see? I think, okay, cool. All right.
Let me just double check. Let me see. Yeah, I can actually see that. Great.
All right, perfect.
Go ahead.
Okay, sorry. Hey everyone, I'm Nihar.
I'm Shimona. I'm Pratibha.
So our project essentially is like a secure and convenient voting system. Basically, the problem we're trying to tackle is that currently in like Davis or most counties that you go to, there's only like 1 or 2 voting offices you can visit. They have a set number of hours that they're open. And many times people have jobs in other places they're at. That makes it hard for them to go during those voting hours to vote. What our kind of project tackles is essentially there are these convenient machines that are placed around the city. Example in like Safeway, Trader Joe's, and other places where you can basically go up, take your phone, connect to like Bluetooth to the machine, and then using that and then connecting to a office, you can basically register your vote that way. So here's a real quick like block diagram of kind of essentially what the architecture of the project is. So on the left-hand side, we have the machine server, which is the actual voting machine. In the middle is a client, which is where the voter actually registers. For example, it could be an app on your phone. And on the right-hand side, it's the actual office server. Essentially what these arrows are showing is the different messages that go in between to complete the transaction to actually complete the vote. There are 7 messages that go through. The first set of arrows, the black arrows, the 1 and 2, that's where the voter essentially sends their voter information over to the voting machine. And the voting machine takes the machine ID and basically generates this requesting authorization message. That message will be encrypted as well. And then that message is then sent back to the client. And then the client, all it does is it forwards it to the voting office. Then the voting office takes that message, which is then the arrows 2 and 3, which is the get auth message, checks to see if the voter is actually registered in the county, and then checks to see that the machine ID matches what the known machine IDs are and generates an either authorized or not authorized message. That's arrow number 3 on the way back. Then arrow number 3 again is forwarded, message number 3 is forwarded again to the machine server through the client. And then essentially the third message, the machine sees that, okay, this is a registered voter. They're authorized to vote here, so let me send them the ballot. So that's arrow number 4. Now the client can essentially choose which candidate they want to vote for. They send this vote back in message number 5. And then the machine server records that vote, updates the votes on the machine itself, and then responds with the has voted message. This message is again forwarded over to the office server from the client. The office server verifies that the candidate has voted and responds with a done message to the client.
So there were a few assumptions that we made while working on the project. So all the voters and the machines have a unique ID which is assigned to them by the voting office, and that is the voter ID and the machine ID. And each message contains the voter ID, that is the voter information. The voting machines are not connected to the internet, and no message is directly sent between the voting machine and the voting office. All the messages go through the client. The voting office is on the internet and communicates with the client. And at the end of the entire procedure, the votes are collected, physically collected from the voting machine.
Oh, yeah.
And also another set of assumption that we are making is with respect to the security of the application itself. And we are assuming that the messages between the client, that the client forwards between the machine and the office, which is messages 2, 3, and 6 on the previous diagram, are encrypted with private and public keys at the site of generation. Another assumption that we make is that messages 1 and 5 are encrypted with machine's public key and decrypted by the machine using its private key. Message 4 is encrypted with the machine's private key and the client decrypts the message with the machine's public key. And the last assumption that we are making would be message 7 is encrypted with the office's private key and the client decrypts the message with the office's public key. I think we'll now head into the live
Yeah.
demo.
Okay, I think everyone can see that. Okay, yeah, perfect. Yeah, okay, cool, perfect. So the first program we have is the machine server. As we can see, oops, let me see if I can see. Oh. Yeah, that's something. There we go. So the first machine server we see is the actual voting machine as the object of the voting machine server. Okay, second thing here is the office server. We again see that it has an object of the My Office server. And the last program, and then once I execute this, we can actually go through and trace the messages, is the actual client itself. So now I'll go through and actually trace what basically happened here. And we're trying to demonstrate two cases. One where the voter is authorized to vote, and second where the voter is not authorized to vote in this county. So starting off on the machine itself, oops. Yeah, there we go. We see that the first message goes through that first arrow we send where the voter sends their voter info. In this case, the voter info is Professor Wu with his ID 0. Then what we see is basically on the client, we see that, okay, we get the response for the send voter info. We have the machine ID, which in this case was just 123. The message was the requesting authorization, and we see again the voter info. Now we go to the office server, they see we get the calling get auth message, which is message number 2. We see that the message was the requesting authorization. The machine ID was 123 and Wu is registered here. So basically they can actually continue voting. So then we see that this message, the voter is authorized, and this is their voting info. This message is then passed over to the machine server. In this case, again, we see that the voter is authorized with the voter info 0 Wu. And then basically now the client can actually vote. So this is the actual ballot. If we see over here, this is the message. We have two examples. We have candidate A and candidate B, just a real easy example. And in our code, we had a Wu choose candidate A. So now that we go back to the machine server, we see, okay, it registers candidate A, and we can see the count that's only on the machine server is that the count for candidate A is now 1, while candidate B is still 0. Now that the vote has been registered, we see the results. We see the result of the vote message, which is the machine ID with the message has voted for voter Wu. And then on this side, we see on the office server side, we see the call to the get receipt, which is message number 6, has voted, that is registered on the office side. And at the very end, we see this done message. So the transaction is complete, the client has voted. Now we're also trying to demonstrate for an unauthorized voter. For this example, we took Chancellor May. So on the machine side, we see, okay, it's calling send voter info message one for voter info May. This message is concatenated into this requesting authorization message, which we see again, which is message number 2 for the machine ID 123 for voter info May. Now going to the office, this is where we actually see this one May is not authorized to vote. So the message that the client gets back is the message was not authorized. And so therefore, the machine won't allow them to vote. And thanks for trying, you aren't authorized. And so the client application exits. Whoa. All right, any questions? Yeah, go for it.
Can you go back to the where you have showed the design?
Yeah, the slide, yeah. This one?
So what do you mean by the client and like?
Can you hold on just one second? I want to record your question. I'm going to pass the microphone. Okay, hear your question.
So my question is, in your model, what do you mean by the client? Is it client like a physical device?
So the client in this example is like it would be an app on the phone. So a voter is what the client is, for example. So they take, let's say it's an app on your phone, you take it up to the Raspberry Pi or whatever device there is in like Safeway, and through Bluetooth you can connect and actually start the transaction.
And so why are you having this another dependency with the officer?
So basically what we want to do on the voting office side is that they're kind of aware of who everyone has voted and ensuring, so the voting, essentially what we want to do is make sure that the voting machine doesn't know who the registered voters are. It's kind of just a way to verify that this person is actually allowed to vote before it lets the vote go through. And so the voting office is kind of like the county's information center. So they know if this is a registered voter, if they're voting on an actual registered machine.
So basically you don't want it connected to the machine server directly.
Exactly.
Of the security.
Exactly. So the machine server is completely offline. The client physically has to go up and be close to it in order to actually do the transaction.
That makes sense. Perfect.
Any other question for this group? Either way, next Tuesday and Thursday, we'll be on the same Zoom link. Everybody is welcome to join. Any other question, either from in this room or remote? Anybody from remote want to ask a question?
No, I don't see anything in the chat.
Okay, so I don't have any question, but you
Okay.
guys, this is great. This is just a comment. Right now, one client essentially only vote on one machine, one server.
Mm.
So one of the vulnerability, of course, is that machine could be taken away, right?
Yeah.
So if today I'm actually going to shopping at Safeway, Trader Joe, and Nugget, so I actually could do just like a Google file system. I can do primary, secondary A, secondary B. So I can actually vote 3 times. And so I have a 3 record, and of course I have to do this 3 times, but it improved the robustness.
Definitely.
If any one is actually get taken away, compromised, I still be able to recover that. In fact, we don't have to do, so you might want to only vote once, because I love shopping. And I probably do 10, all right? So everyone has my vote. So it's actually make the system maybe more robust.
Definitely.
Okay, all right. Any other question? Okay, good. So thank you very much for first group, and we're going to,
Thanks, guys.
thank you. Okay, we're going to have the second group come up.
Right, this I'm guessing.
You want to share your screen?
We'll just share.
Oops. Oh, yeah. No, but oh, sorry. Whoops.
That's
and then
okay.
you're just sharing the Zoom.
Because if you use this, the rest of the class won't be able to see it
Okay.
unless you share the screen.
Okay.
But you know what? We can do that as well. We can let you use this one, and then you still share your screen. Would that be okay?
Sure.
Just push. Perfect.
Where is it coming?
Or maybe the back.
Hmm,
It doesn't come up.
Let me
Should,
push back.
okay.
One more time.
I think it's.
Should we just share your screen?
Sure,
Okay.
that's fine.
Sorry.
No problem at all. This is always unreliable. Technology is not so good.
Definitely.
Hold on. Okay, that's okay. Let me.
Instant fail.
No, that's okay. It's not your.
There we
It's
go.
not your
Okay.
problem.
Okay, perfect. I think, and is the audio coming from your computer? Glenn? Yes.
Either way is
Okay.
fine. Yeah,
Okay.
So,
go ahead. Yeah.
yeah, our project is on coupled cohabitation verification via ecs251. I'm Charlie, this is Dolores, and this is Annie. So today, our agenda is we're going to talk about a problem that we are addressing, and there's two different types of like sub-problems within this problem. We're going to talk about a solution proposed with ecs251, and we're going to give you some use cases, a live demo or recorded/live demo, and then we can open it up to talk about some future possible work.
Okay, so I'll talk about the first problem that we face in the real world that, there are, well, I'll go over it. So the first problem is that for a lot of couples, they live together for a long time, but they are not married. They're not legally married for various reasons with or without their control. So, or in some cases, their marriages in some jurisdictions are not universally recognized some elsewhere. Because of this, they may face discrimination when in different areas like in housing or healthcare or benefits and like adoption rights. These issues are nowadays maybe less so in the United States, but they're still prevalent elsewhere. And just tell you one personal example. And in Shanghai, where I have lived for a long time, if you're not a local resident, you need to purchase an apartment as a couple, as a legally married couple. So this creates a lot of difficulty for unmarried couples. And I would argue that proving that two people lived for a long time is more important, like their relationship is possibly more like I would say secure than marriage license, for example.
So the second problem we'll be talking about is marriage-based immigration fraud. And so some different types of immigration fraud for marriages is when a citizen marries a foreigner for money. A citizen could marry a foreigner as a favor, like they're a friend, they don't want them to have to leave the country, or a foreigner misleads a citizen. So to combat against this in the US, a couple who's trying to apply for immigration rights for one of the partners must prove that they have a bona fide marriage. This supportive evidence can include like joint leases, joint finances, proof of shared activities, proof of their wedding, things like that. They also have to undergo interviews with immigration authorities. And it's a very long, drawn out process that takes about a year for just the first step in the process. So these statistics are just to give you an idea of the prevalence of the problem. Of course, they're not a perfect measure because these are just various forms in the process and the denial rates associated with them. So of course, these are not all fraud, but it just gives us kind of a picture of the problem. And so what we're trying to answer is here is how do you determine a fake marriage versus a real one? And I can't talk about fake marriages without this BTS video, so you can watch that on your own time.
What was that?
It's a song, it's called Fake Love, and we were talking about fake love, so I just had to include it.
It's kind of like K-pop.
Yes, it is.
Oh, that's my daughter's favorite.
Oh, I need to meet your daughter.
I have to show her.
Yes, please.
Show them actually, I have two.
Okay, so we propose a solution using ecs251, which we studied a little bit in class. So we know it's like ethics-aware application. It's got a human in the middle, so it requires a human to be present to operate whatever you're trying to do fully. In addition to your human, there's internet connected clouds and edges. It's going to be community-based, and there's going to be this trade-off between speed and efficiency without the system versus like a more security. So we thought this was a great solution for this kind of problem. So there's going to be two different processes within our solution. There's going to be a check-in and a data sharing process. So check-in, both clients, which is the couple, they connect to their home server, and they can use like biometrics to confirm their identities. And then the home server, the Raspberry Pi at their house, is going to record their check-in. Then the next process is data sharing. So one of the partners can connect with both the home server and the organization server. So we'll go into two use cases where you'll see the organization present. And so this is done via remote procedure calls. And yeah, so it gets the information. So this is just a visualization of what the check-in process is going to look like. So you see the couple, they both have their mobile devices. These are going to be the client devices with the server, the home Raspberry Pi. And after a year passes, they might be checking in indeterminately. So maybe a couple times throughout the year, who knows? And so they'll rack up the score of how long they've been together over time. So we have a couple of use cases. Our first one, which used to be more of an issue in the United States, but now it's not the case, but still an issue elsewhere in the world, like in Japan and the United Kingdom. So if your loved one, if your significant other is hospitalized, maybe you're not allowed to visit them because you're not legally married. So in this case, both partners would be present. They can both share their data or connect to their clients to the server, and the organization will receive confirmation like, hey, yes, there are 3 check marks all around, we're good. And then the partner can visit their partner in the hospital.
And the second use case is what we talked about. It's solving the problem of this immigration fraud. And it works exactly the same way, except we're just swapping out the hospital for a government office where their server would be located. And so one member, well, both members of the couple would go to the immigration office. They connect to their home server as well as the immigration office's server, and they're able to exchange this log of check-ins. And so then the immigration authorities review that log, and if all goes according to plan, the partner is granted permanent residence. Okay, so now we'll move into our demo. We actually recorded this and I'll just narrate it. So here we go. Okay. So first I'm just showing you the files we have present. We have the client, then we have a home server, and we're talking about the use case of hospitals here. So we have the hospital server. So now I'm starting up the home server and starting up the hospital server. And then here I'm going to run our first task, which is making a log. And so I'm just running the script with make and with a unique identifier. So here you can see on the client connected to the home server. There's no need to connect to the hospital server at this point. And then on the home server, you can see we wrote a check-in to this log, which has the unique identifier with it. And then we're just changing the ID and doing the same thing for the other partner. And then now we're doing the send process. And so the send process, the client is actually connecting to both the home server and the hospital server. And then on the home server, you can see we are reading different records from the 2 logs. And here on the hospital server, you can see we're writing those records to the hospital's log. And then you can just see these various files. And let's see, how can I move this? Okay. Hopefully, okay. So there we go. So finally, some future work. We hope to be able to verify relationships other than those of just romantic partners, such as close friends, And this could help with hospital visitation rights and healthcare decisions. We also hope to support other methods of verification, such as through voice recognition. So you could check in on a phone call, and it would be able to determine who you are via voice recognition, which would help with like long distance couples in the military, et cetera. And then finally, and most importantly, we hope that this software can bring about policy changes, because there is a lot of discrimination against unmarried couples, and there's also a lot of inequality in the ability to gain citizenship. And so we hope that our software can be used to address those problems and inspire policy changes. Any questions?
Any question? Okay, I have two comments, not question.
Okay.
Okay. Number one, I feel that both your group and this group, they actually did a better job in my lecture. So I really should have done more for you guys to present. That's number one I got. Number two, I want to say that the importance about your work is that today, if I want to verify if two people has a relationship, the corporate or the government, they want to find out, they have to go through things like a Facebook or those kind of public channels.
Yep.
So not only those channels are unreliable, furthermore, our privacy is actually in danger.
Yeah.
So I'm not hoping that the technology that's involved, the core technology is really, I can control the data. I record all my activity under my control. And that capability become mature, become trusted by our society, which I think you guys can contribute to that process. Then the whole world will be changing for a different way about evaluating. Yeah.
Absolutely.
Yeah, excellent. Thank you very much.
Thank you.
Okay, are there any other group in this room that you prepare that you want to give a demo or, but you didn't tell me earlier? Okay, that's okay. And all right, so we really appreciate those two groups. What I'm going to do is that I'm going to turn off the recording, and then I'm going to change the class into helping you to solve your problem, either your homework 2, homework 3, or final project, okay? And at the end of the class at 3 o'clock, I'm going to move back to academic search. So if you want to do any kind of programming issue face-to-face, you're welcome to do that, but it's also on Zoom, over Zoom as well, okay? Let me turn off the